We have one question from the chapter application of derivative that is based on maxima minima. It says an open box with a square base. So we have a box with a square base and it's made up of a given quantity of material. So the quantity of the material is given, that is fixed, and whose area is mentioned as C square unit. What we need to show is to maximize the volume. So the maximum volume, we have to maximize the volume or prove that the maximum volume is C cube 6 under root 3. Now let's say if I try making a cuboidal box with a square base. All right, let's join spaces. So I'm going to take its, say the length base as x and s. As you can see, it's a square base, so it will be same over here. And I'm taking the height as h. So what we are given about the surface area. So how do we calculate the surface area? It should be what? Curved surface area, which is 2h bracket L plus B. So over here, L and B is x. So we may write x plus x. Right. This is the curved surface area or lateral surface area, 2h bracket L plus B, plus area of the base. And we have only one base as it is open from the top. So it will be x into x, that is x square, which is, as per the question, it is mentioned as it is c square. So we can simplify. This is 2x into 2h, that is 2xh. 2 into 2 is 4, right? It's going to be 4xh plus x square is equal to c square. And you should remember that this is a constant over here. Now, as we proceed with the questions, what do we find more about it? That we have to maximize the volume. And what is the volume of a cuboid? It is length into breadth into height. So we can see and length and breadth are x each. So I can replace this with x into x. This is x multiplied by x into height, which is h. Now you can figure out from here that we have to replace, need substitution, as we cannot find derivative when we have two different variables or more than one variables. So what we can do further, we can replace this h here, right? I can replace this h. I'm going to do that is only. And this h I'm going to replace with h from here, because c is a constant. So if I extract h from here, it's going to be what? It should be c squared transposing this x squared to the other side. It is x squared divided by 4x. Yeah, I'm right. Now let's say if I continue calculating the volume, so it's x into x is x squared. And as I said, I'm going to replace this h, and h we found out to be, this is c squared minus x squared over 4x. So if I open this bracket, it's going to be applying distributive property. It is x multiplied by c square. So it's going to be what? This on multiplying. All right. This on multiplying, it is become c square times x, and x multiplied by x square is going to be x cube, that divided by 4. So now I can find its derivative. Let's say if I write 1 by 4 and c square x minus x cube. In the next part, I'm going to differentiate this with respect to x. So differentiation is what is going to be dv by dx is equal to 1 by 4 being coefficient, and c square is a constant, and derivative of x is 1, minus the derivative of this is going to be 3x square. Now for maxima or minima, this has to be equated with 0. So yeah, but then we can first find the second order derivative also. So this is d square v by dx square. As you can see, it's 1 over 4, and this will become 0, and this is minus 6x. So it's minus 6x. We can reduce it. This is 2 times 3 times. So we are getting minus 3 over 2x. And as you know, for positive x, we are going to this as less than 0, and hence maxima. Now let's continue with this equating this. dv by dx with 0, like I'm equating with 0. So equating this with 0, what we are going to get is c square is equal to 3x square. Repeating, since for maxima or minima, dv by dx is equal to 0. This equated with 0 is same as this is 0, and 1 by 4 vanishes, so we get this. When equated with 0, we get c square is equal to 3x square. All right, this is the relation that we have obtained here between c and x. Now check here, we had to maximize the volume. And what is the volume? From here we can see the maximum volume. We can also say that this is what? This is negative, right? For all positive values of x. So this is less than 0. Let me write on. Where should I write on? I can write here d square v by dx square is less than 0 for x for c is equal to c square is equal to 3x square. Hence maxima. Now we have to also find the maximum value. So I'm going to replace this x from here, right? From here, because we need the answer in terms of c, right? And that's what I'm bringing such changes over here. So let's say continuing with this, from here I can see v is what? This is v is equal to 1 over 4 c square. We need c in terms of c. From here, what is x? From here, what is x? You can find out that x is actually c square c by under root 3, right? On transposing this, c is this. So this is c over under root 3 minus x cube, right? So x cube is x into x, which is cube of this, right? So cube of this is what? C cube over root 3 cube is what? Root 3 into root 3, 3 root 3. So on simplifying, we'll get the answer, but then I have to erase this portion in order to find the final answer. Now I'm doing it over here. This was v is equal to 1 over 4. I'm simplifying this part. It is what? C cube over root 3 minus c cube over 3 root 3. So this is v is equal to 1 over 4. I can take c cube common. So this is c cube on taking out common. And with further simplification, LCM is going to be 3 root 3. And this is 3 times. Now this is 3 minus 1. So yes, we are 3 minus 1 is 2. And if I reduce this 2 here, this cancelled with this 2 times, we are getting c cube over 6 root 3. Yes, that is what we needed to prove over here. And we'll say that this is the maximum volume in cubic units.